One of the problems with z-scores is that they're always between -1 and 1, and those aren't especially numbers that humans like. Humans don't like numbers like -1.15 or 0.63. We like numbers that are similar to counting numbers. We like the numbers 1 through 10 the best, and then maybe the next set of numbers that we like the most are the numbers 1 through 100. We don't really like decimals. We don't really like negative numbers. We like counting numbers. Well, since z-scores are always these decimals, and sometimes they're negative, what we can do is we can transform them so that they're easier to use. Now, by transform, I mean we put them through some formula so that they become numbers that mean the exact same thing, but are easier to handle. So we're going to look at how to transform numbers into t-scores, and that's a capital T, where rather than z-scores having an average of 0, t-scores are going to have the average of 50, and instead of a standard deviation of 1, they're going to have the standard deviation of 10. So this is especially useful when you're dealing with humans, and humans have to understand numbers. When trying to figure out if one person is better than another, if one scores better than others. The t-score is the formula that we're going to use is it's going to be based on the z-score. We're going to take that z-score, multiply it by 10, and it's going to go up to 50. So now z's are usually between -1 and 1. They can be more extreme, -2 to 2, sometimes -3. Rarely will you get a -4 or a 4, but you'll see that no matter what, the t-score is going to be positive. So this is a way of getting z-scores so that they're always possible and easy to use. For example, a z of 1, which is not unusual, would be 1 times 10 plus 50 would be 60. So 60 means that a score is 1 standard deviation above 0. A z of 0, which means that it's average, would be 0 times 10, which is 0, and be 50. And a z-score of -0.5, now that's a negative number and a decimal, something that people don't like. Put it in this formula, and we get a t-score of 45. And people say, oh yeah, 45 is okay. And we can compare the numbers 45, 50, and 60 a lot quicker than we can compare the numbers -0.5, 0, and 1. So a lot of times people report scores as t-scores. Now, there's other types of transformations of z-scores also. Previously, we saw IQ scores, and that's simply a transformation of cognitive ability. Sometimes it's based on a standard deviation of 16, so we'd use this formula, 100 plus z times 16. Sometimes it's based on a standard deviation of 15, and it would be this formula. Similarly, there's the SAT type of score. Typically, it goes from 200 to 800, where you take the person's z-score, times it by 100, and add it to 500. That'll give you an SAT type score. And the GRE is similar, except they've camouflaged it so that you can't really see what it is. You take a person's z-score in a topic, times it by 8.6, and add 151 to it, and you get a GRE score. So these are t-scores. These are transformations that make it easier to figure out what's happening with numbers. Now, we're going to look at an example where a t-score might be useful, but we're also going to go back to the question of weighted averages and talk about when might we get in trouble with weighted averages. And if we're creating a weighted average and the different things that we're weighting have different standard deviations, different variances, we're going to need to use normalized scores, or we're going to get crazy things that are mixed up. Now let me bring some data over here. I have got some candidate data from 3 candidates, Winnie the Pooh, Piglet, and Eeyore. And all 3 applied for the same job, and they have gone through various tests. They've been interviewed, their resume has been evaluated, and their cover letter has been evaluated also. And the interview goes on a 1 to 5 scale, and it's going to be 40% of the weight. And turns out Winnie did wonderful on the interview. He was just so lovable. People didn't want to see him leave. Piglet did pretty well on the interview. He got 4, and he was a little anxious, and that kind of showed, but he still did pretty good. He got 4. And Eeyore, poor Eeyore, he didn't do very well on the interview. He was kind of depressed, and he wasn't very enthusiastic, and he ended up saying he didn't think anybody cared. Eeyore only got a 2 on the interview. Now, on the resume, which was also graded on 1 through 5, and was 40% of the weight, Winnie the Pooh and Piglet both did really well. They've had a lot of really good experiences, and they were able to write about them and tell about them and cast a vision for what they were able to do. Eeyore, on the other hand, it had spelling errors in it and a few grammatical mistakes, and he didn't bother finishing it or putting in very much details. He only got 3 out of 5 on his interview. So far, Winnie and Piglet have done much better than Eeyore. However, on the cover letter, which was graded on a 1 to 100 scale, so this is a much different scale than the interview or the resume, both Winnie and Piglet, they didn't do real well on the cover letter. They had some grammatical errors, and a few sentences weren't as smooth as they could be. Eeyore, however, he had Al proofread it for him. Now, Al is very smart, and he fixed all the typos in the cover letter, and he made all the English flow beautifully, and Eeyore got 98 on the cover letter. So Winnie the Pooh did best in 2, Eeyore did best in 1, Piglet tied for best in 1 and did kind of the middle for the others. And so if we were to do a weighted average like we have been doing before, if I click on here, you can see it says a sum product. If I do the sum product of Winnie's scores and the different weights, and divide them by the total weight, Winnie got 21.4, Piglet got 21.2, and Eeyore got 21.6. He got the highest score. What happened? He completely failed 2 of the 3 tests, but because of the cover letter, he got the highest score, and the cover letter was only supposed to be 20% of the ranking. The other 2 were supposed to be far more important. The reason this happened is because there's a lot more variance, the standard deviation is much higher in the cover letter scores. So Winnie the Pooh got 12 points lower, or 11 points lower than Eeyore, and that just made Eeyore look so much better, because even though Winnie got 3 better on the interview and 2 better on the resume, it didn't make up for the 11 better on the cover letter. So what are we going to do so that this doesn't happen? What we need to do is we need to standardize the scores. We need to make them like into Z-scores or T-scores, so that everything has the same variance, the same standard deviation. Okay, so let's look at some more data about these tests. We have not only Winnie the Pooh, Piglet's, and Eeyore's data, we've got kind of what everybody does on the test, because that's what we need for standardized scores. So for the interview, the average interview score is 4 out of 5, which you would kind of expect to be the case, because people generally like people that they interview. So even though 3 seems like the midpoint, people usually get 4. And the standard deviation was 1.1 on in the population. The resume, again, the mean was about 4. Some people get 5, some people get 3. The real bad ones get 2, and those people that write it with a crayon, they get 1. Again, the standard deviation here was 1.0, and then for the cover letter, which goes from a 1 to 100 scale, the average cover letter gets 90 with a standard deviation of 15. So they might be all over the place, but because the standard deviation is so much bigger, we expect it to have more of a variation of scores than the interview and the resume. So let's standardize these scores. Let's first of all calculate a z-score for everybody. So we've got the interview, resume, and cover letter, and that's what we have here in the same order. The interview mean, the resume mean, and the cover letter mean. So we're going to first of all calculate the z-score. And we're going to use the formula raw score minus the population mean divided by the population standard deviation. That's the same standard formula for the z-score. So we're going to put in equals and then parentheses on the top. We want to base it on Winnie's score up here. So he has a 5. So this is cell F5. So I'm going to put in F5, and then we're going to subtract from it the interview mean, B13. Now, I could put that in as an absolute reference, $B, $13, but I'm gonna do it as a semi-absolute reference because we've got a bunch of means we're going to calculate, and they're all in column B, but here it's in 13, 14, and 15. And here we've got the same order. This would correspond to 13, 14, and 15 here. So I'm going to put the $sign only on the B, but not on the 13. So so I close the parentheses, and then I'm going to divide it by the cell D13 is the standard deviation here. So I'm going to do the same thing. I'm going to do $D, because I always want it to come from the column D. But this first one I want to be for 13, and when it calculates next down, I want it to go down to row 14, and that one down to row 15. So I press Enter. Now we have the z-scores for Winnie. So in the interview, he did a little bit above average. He got a z-score of 0.91. On the resume, he did one full standard deviation above the average. So he got a z-score of 1. And on the cover letter, where he got 87, the average was 90, and he did a teeny tiny bit below average, minus 0.2. Now, something that we can do with these cells, if I select these 3 cells, we base this on the formula F5. Now we can move it over to Piglet and Eeyore, and it'll base it not on Winnie's scores, but on Piglet's scores. And so we saw Piglet, he did average on the interview, he did pretty good on the resume, and he did slightly below average on the cover letter. But Eeyore, now we can really see how he did. He did way below average for the interview, he did below average for the resume, and he just did a little bit above average for the cover letter. Now we could calculate a weighted average with these z-scores, but then we'd be reporting them as negative and positive decimals. So let's calculate a t-score. So for Winnie, it's going to be based on cell F19. So I'm going to use this formula, equals 50 times 10 times F19. So equals 50 plus 10 times F19. And I forgot the star, so I don't want that correction. Okay, so I forgot the star in there. I have to put the star for the multiplication. Equals 50 plus 10 times F19, enter. And now we've got t-scores for everybody. We can, we got 59 for Winnie for his interview, 60 for his resume, and 48 for his cover letter. Now we can do the same trick that we did before and bring everybody's over here. And now we've got t-scores for everybody. Let's get rid of the decimals. I'm gonna click this to get rid of decimals. No, this one that gets rid of the decimals. So here we've got the t-scores for everybody. So remember, 50 is above average, and we see that when he did above average, a little below average. Piglet, average, above average, a little below average. And then Eeyore, way below average, just a little bit above average. Now let's calculate the total weight, because the interview and the resume are supposed to be 40% of the score and the cover letter 20. So I'm going to do equals sum, and we're going to go from E26 to E28, those three numbers, and that's going to add together to be 1. And now our weighted average, we're going to calculate for each one. We're going to use the sum product of this row times the sum product of this divided by the total weight. So that's going to be equals sum product, and we're going to have E26. It's always going to be this one, so we can put the absolute cell value, $E, $26. Then we're going to go to $E, $28. That's going to be the first argument. Now we're going to put in Winnie's scores. He's in column F, but we want to calculate it for Piglet also, so we're not going to make F be the absolute value. We can do F26 F28, and then we're going to close parentheses, and we're going to divide it by that total weight, which is in cell E30, and that's going to be a absolute reference. It's always going to be in that location, $E, $30. I press enter, and we have a weight of 57.2 for Winnie. We bring it over to Piglet and Eeyore. Piglet gets 53, and Eeyore is only 39.8 now because the cover letter has been weighted correctly. The two that are most important, the interview and the resume, by normalizing these scores, they carry the weight that they should. So Winnie is the candidate that we should choose.